let us take a look at 2022, day 12. Hill climbing algorithm. You try contacting the elves using your handheld device, but the river you're following must be too low to get a decent signal. You ask the device for a height map of the surrounding area. Your puzzle input. The height map shows the local area from above broken into a grid. The elevation of each square of the grid is given by a single lowercase letter, where A is the lowest and B is the next lowest, and so on up to the highest of Z. Also included on the height map are marks for your current position, S, and the location that should get the best signal, E. All right. Okay, your current position has A and the best signal is Z. Okay. You'd like to reach E, but to save energy, you should do it in as few steps as possible. All right, so it's just a maze search. We can grab this as, there we go. Grab this as our test input. I was able to use the tab there for speed because we already had the file from yesterday. During each step, you can move exactly one square up, down, left, or right to avoid needing to get out of your climbing gear. The elevation of the destination square can be at most one higher than the elevation of your current square. That is, if your current elevation is M, you could step to N, but not to O. That also means the elevation of the destination square can be much lower than the elevation of your current square. Oh, okay. So you could go from like M to A all the way through N. So our range basically is A through current location plus 1. That makes sense. For stepping. So we can go from Y to P, but we can't go from P to Y. I think I understand. Cod3 Monk says that's a nice little touch. Oh, for the edit? Yeah. Makes me feel better. So here you start in the top left corner. Your goal is near the middle. There's S, there's E. You could start by moving down or right, but eventually you'll need to head toward the E at the bottom. Why? Oh, because that's the only path that works. E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X. Oh, and then you can't go there because that's Z. And okay, so you kind of just spiral around. Got it. In the above diagram, the symbols indicate whether the path exits each square moving up, down, left, or right. Right, okay, so I see. So down, right, down, and this way, and then down, and then we spiral in. Yep, got it. This path reaches the goal in 31 steps, the fewest possible. What's the fewest steps required to move from your current position to the location that you get the best signal? All right, well, let's get our input. Oh my. Okay, it's 41 lines long, and it looks like it's 100 and, I don't know, 10, 20, 30, 40, 50. This is 100 wide. So it's not quite 150 wide. Let's just take a quick look just to see. 143 for the NeoVim, which means, yeah, that's how many characters wide. So it's 143 wide and it's 41 high. All right. So it's not a fantastically huge grid. Now, where's the start and end? So if we look for capital S, it looks like it's right here. And where's capital E? Oh, it's on the same line. Interesting. Okay. I don't think it matters too much. So I think let's start by, do our usual setup. There. So create day 12. Like this. Add a day 12. There we go. Create the file. Generate it. 22, day 12. And build. And then we should get unsolved, unsolved. Perfect. Next, we need to read the file. How do we want to store it? I guess we could just store it as a grid of a pair of vectors. So grid would be a vec of. we want to store it as chars or U8s, or let's do U8s. I don't know if that's simpler than chars. Maybe it is, maybe it isn't. I don't know. So this would be let lines equals AOC lib read lines input 20. Oh no, we're going to do the test input first. Test input dot text. And then for line in lines, we're going to split this into chars and then map it into, okay, and so it'll just be self grid dot push. Oh, yeah, we have to find the start and end locations. Okay, so let's say let grid line is equal to line chars. We'll map it into a U8 and then collect into a vec of U8. We're going to have a start and end. Like that. Then we can look in the grid line to see if there's a starting point. If let sum starting point is equal to grid line iter position of position point, I guess. Point is equal to the starting point. Then we're going to set a self start is equal to start. This is row col. So enumerate row comma line. So this will be row comma start point. There we go. Epic Blog, hello. Epic Blog says, have you struggled with any of the AOCs this year? Has it been smooth sailing so far? I did feel like I struggled with like day 10 or day 9, I forget now. I mean, some of them have been particularly tricky. Yesterday's was pretty smooth sailing. I think most of the problem with yesterday's was parsing. Right? Now that was the so far the hardest part. But there's always this one puzzle, right? Every year where there's one puzzle which just kills you. And I'm hoping that the part 2 for this one isn't going to be one that kills me, because the part 1 looks like it's pretty straightforward. It's just a path finding, and I'm thinking I'll just use a fill search. Endpoint is equal to grid line iter position p is equal to the endpoint. Self end is equal to row endpoint. That looks good. And then we'll just push self grid, push grid line. Let's see if that works. Not quite. Oh, because I forgot to actually call it. How about you, Epic? Have you been going through all of these this year? Fix that. Iter. Lines iter enumerate. And we can't do that because we need to reference it. There. Okay, and then in part 1, let's just print out println width, height, just so we can have those. So self grid of 0.len, grid.len, and then println start at here and at here. Let's see if we got all the values we need. Self start, self end. Senf. Senf means mustard in German. And just a little bit of trivia for you. Epic says, nah, I've been way too busy, but I plan on telling everyone next year I'm going to need to set aside some time for AOC. It is a lot of fun, and you don't, you don't have to do it the same year that it comes out, right? I've been working my way through the very early years. You can see how he's learned how to write the puzzles better over time. So 2015, the puzzles were written well. Don't get me wrong, but he's gotten better at hinting and cluing people into what's going on over time, which is nice. So started 0, end at 2.5, and that sounds right because started 0, end at 2, 1, 2, 3, 4, 5. Yeah, okay. So we're finding the start and end point. At least I assume we're finding the start point because it happens to be 0, 0. Let me just prove self start is equal to 1, 2, 3, 1, 2, 3. It should still set it to 0, 0. It should still find it. It does. Okay. Thank goodness. All right. So we have the maze. We have the place we're going to start. And we have the place we're going to end. Oh, wait a minute. Because I'm thinking, well, okay, we'll just do a flood fill, but now we have this S and E in there instead of an A and a Z. Epic says, saw that some weirdos have solved some AOC puzzles with VHDL. I mentioned this because I'm currently working with VHDL. Yeah, people use all sorts of strange methods to solve it. I remember there was one. It was a few years ago where somebody just made a logic circuit using a breadboard to solve something, which was kind of neat. But people have solved it on Game Boys and NESs and Atari 2600s. So it's really interesting to see that if you check out the Reddit. And the other fun part of Advent of Code is seeing all the visualizations people create for the different days. Some days are more easily visualized than others. And so, some of the fancy ones get kind of neat looking. All right, so I think the right way to approach this is to just do the flood fill, like I was saying. We can just start at our current location, and in order to do the flood fill, I think I want to replace the S and the E with an A and a Z, which means I need to mutate this, and I have to say grid line of start point is equal to A, and grid end is Z, and that way we're not lost when we're trying to calculate things. We don't have to do special case the S and the E. So we'll create a visit vector, and then we need to populate the visit vector. So because the basic structure of the thing is going to be while let sum location equals to visit.pop. We're going to find locations around us that can get here. Here being, to lock, right? Because you can go one direction, but you can't go the other direction, right? You can go from Z to S, but you can't go from S to Z. So we have to be careful about which locations we choose. And then once we've found all the locations, we say look for a min, the smallest value around us. Add 1. If that is smaller than our current location's path dist, update. And then, actually, let's do this kind of Python-esque here with a tab. Update current location, path dist, and then add insert into to visit the locations around us. which we should already have from here, right? And then we just keep looping until our toVisit is empty. And then once our toVisit is empty, we can just look for the min. Output is equal to the... No, output is going to be equal to the path dist of endpoint. Perfect. So we need to keep track of where we still need to visit. We need to keep track of our shortest locations. The shortest is just going to be a hash map. Let's define it, hash map. And it's going to be a tuple, which is our location, and the amount of steps it takes to get to that location. Which means we need to do this. So far, so good. We do want to insert into the hash map our starting location's distance, which is 0. And that way we'll build off of the 0 for everything around us. So how do we figure out what's around us? That's going to be a little trickier. We can create a let dir equals up, down, left, and right. Right? These are the directions. These are the offsets you have to do from where we're going to be. And then lock is just an unknown. Perfect. Oh, we do have to insert in the toVisit array. We do need to insert all of these guys from the offset from the starting point. So toVisit extend, I think, and dir.iter map d. And self-start is just a tuple, right? Oh, well, fudge. So these are, you're right, these are usize usizes, but we don't have this, there's no such thing as a negative usize. Okay, then we have to get fancier. Annoyingly fancier. Let iStart is equal to self-start 0 as I32, self-start 1 as I32. That's our iStart. Now the problem is we need to, okay, so now we're going to map this iStart 0 plus D0, comma, iStart 1 plus D1. But they could go negative and we don't want them to go negative, so we're going to say dot filter for any position. Position 0 has to be greater than or equal to 0, and position 1 is greater than or equal to 0, and position 0 is less than width, which we don't have yet, but I'll add that in. Position 1 is less than height. And now we have to map it back to usizes. And that extends our toVisit array. And that should be, yeah, now it's a vec of usize. Okay. That is annoying, because we're going to have to do that everywhere. Everywhere we use dir, we have to do this. These 3 map steps, map, filter, map. I wonder if there's a better way. Well, I mean, I could just make it a function, right? Function get points. Or get surrounding points. And what I can do is, let's make it a function on this, so I can just create a constant for this. So we can say impl AOC 2022 12. Put this here and say const usize semi-4, and it has to be uppercase, and then surrounding points for a given point, right? And it's going to return a vec of usize. And we should just be able to do this. And instead of calling it iStart, oh, yeah, we'll call it iPause. What is it unhappy about here? Did I forget? Am I in the middle of something up here? No. It's not happy about something because it won't format for me. If it won't format, that means there's something I did wrong. Oh, there's a comma there. And then actually that's it, right? So then we just want to say collect. And hopefully the collection will, there we go. So now all we have to do is say extend of self get, what did I call it? Surrounding points? Of self start. Right? Well, let's see what blows up now. Self. And iStart doesn't exist. This should be iPause. And then self width and self height. So we can just store those. When we create everything, we'll just set those. Width is going to be usize, and height is going to be usize, right? And then we just set those here. Self width is equal to self grid 0.len, and height is just self grid len. And we can get rid of these lines here. We don't need those anymore. Okay. Still not good enough. Oh, because I forgot to put the self parameter on here. And that means I just have to say, yeah, I already put self.get surrounding points. Okay. Are we getting closer? We're not, because these have to be I32s. That was the whole point. All right. Oh, right. I'm going to do it this way then. Let width equals self width as I32. I'm going to let the compiler clean this up because the optimizer should optimize that out. All right. So we popped off all the visits and then we didn't have any output, but that's fine. Okay, let's actually do the work. So we have our shortest thing here. Let's put it there. Keep them all together. We create our to visit array. And now we want to say, okay, now we find all the locations around us that they can get to lock. So we'll say self get surrounding points lock dot iter. And now we want to check each point to see if it's something that we're allowed to get to. So let's set our current height. Right, because this is a height map. I don't know if I want to use the word height though, because height is already referring to the height of the grid. Let's call it elevation. Is equal to grid of lock 0, lock 1. Right? So we're going to iter on that. So we're going to say let valid. And then we're going to filter for each position that we look at. The grid of pos 0, pos 1 has to be, plus 1 has to be greater than our current elevation. Right, because we're allowed to go from Y to Z, but we can't go from S to Z. Okay, I think that's right, and then we'll collect those. I think it's just usize. Size. Right. So those are all our valid locations, I believe. Of course, it doesn't work because I have to put self grid everywhere. What else am I missing? Oh. Isn't this a usize? It is. Oh, do I have to map it? It had two ampersands on it, right? So oh, okay. So maybe the map takes away one. All right. So now we have all the valid locations. Our new path distance, let new path dist is equal to valid at iter. Now we're going to look in the shortest to find out which one's the shortest. Map. Filter map. Let's do a filter map. That way we don't have to do anything. Shortest get pause. Right? And we want to get the minimum distance on that one. And that's an option usize. All right. And then we want to add 1. Right? Because that's the shortest path dist to the surrounding one. And then we want to add 1 for our step. Okay. And then all we have to do is say if, oh, we have to get the current distance. Let current path dist is equal to shortest entry of our current location, or insert usize max. If current path dist is greater than the new path dist, then we want to set it. So cur path dist equals new path dist. And then we can extend. Oh, maybe we do this in 2 separate steps because these are our let points. I just want to be able to copy it. Self get surrounding points of lock. And that's the vec. And then we can just say points iter here. And that way we can just say here to visit extend by points. Iter? Do I have to say iter there, or can I just say points? Yeah, and that's this one. Look for the smallest one around us and add 1. Right, there's the add 1. That's smaller than our current location. Right, update the current location and then extend the visit array. Okay. And then the output, let's get rid of the comments here. And then the output is just going to be shortest get self end unwrap. Let's see what happens. Kaboom! Oh, so this needs to be unwrapped. And this needs a star in front of it. And we compute it, and we panic. Okay, so what are we panicking on? Line 65. That's here. Oh, it's not finding a min. Okay, this is what I was afraid of, is that we would be ending up with a situation where we're not getting all the right values that we're looking for. Okay, if we can't unwrap on that, we can print out what we've got so far, right? We can say if new path dist is none. I wonder if that means like we hit a dead end or something like that, and it just, let's find out. Println shortest, and then we'll just say standard process exit 0. Otherwise, let new path dist equals new path dist dot unwrap plus 1. Right? And what do we get? So we got 0, 0 has a distance of 0. 0, 1 has a distance of 1, but for some reason it's not looking down here. Do we have invalid points here? Println points equals points. Oops. What do we got? Come on. Okay, so it's searching a couple of times. The first time we're going through, we see 1, 1, 0, 0, and 0, 2. Right, because we're looking, we should say what we're starting from at lock. That way we can see what we're doing. Starting at 0, 1, which is this A here. We have a 1, 1, which is this one. We have a 0, 0, which is that A, and a 0, 2, which is that B. So those are the 3 correct points to look at. Then apparently maybe we're not inserting this properly, because now we're going to look at 0, 2, which is this B. And we're going to we should look at A and see the A there. Okay, let's see what happens here. Println setting lock to new path dist. So we should see that. Setting it to 1. Yep. Now starting at 0, 2, it should see the 0, 1 here. Is it not? Oh, maybe it's being filtered out. Oh, maybe I have my filter wrong. Println valid points valid. It's leaving this one off because we're at 0, 2. It should find 0, 1 because A is less than. Oh, should this be less than or equal to? Yeah, that's the bug. Okay, and we're looking for what? 31 steps. We didn't get anywhere near 31 steps. So we still have a problem. We still have another bug. So we got past the first bug. Starting at 0, 3, which is this Q. We have points 1, 3, 1, 3, which is R. 0, 2, which is the B. You can go this way, but you can't go the other way. And 0, 4. Okay. So we should not be getting from B to Q. Right? And from starting at 0, 3. Oh, this is the bug here. Now we have a different. Oh, okay. So this must be self grid pause 0 pause 1. Right. This is the position that we're looking at, and we're saying that 0, 3 is a valid point to get to from 0, 2, and it isn't. Oh, you know what it is? Yes, it is, because you can go from Q to B. So if Q had a point, then we'd be able to do it. So I think we have to put valid here. No, that still doesn't do it. This looks right. This looks right. I don't see anything wrong there. This seems like a you know what we could do here is instead of exiting, maybe we can just continue and just keep looking. Why stop, right? Ooh, there we go. And now we have too much output. It did exit with a panic though. Cargo run. Let's see what the panic is. The len is 5, but the index is 5. Really? And that's on line 58. Oh, interesting. So surrounding points is returning invalid points, which it shouldn't do because it's filtering out any invalid point. Do I have the width and height wrong? The width is, yeah, that's right. That's right. Pos 0 has to be greater than or equal to 0, pos 1. So it looks like we're going off the end of the grid. Let me print out our points here. Oh, I did. That's what I did. Okay. Let's just say tail. And it should show us that we got, yeah, we got a 5-1 in there. Oh, do I have, oh, I do. This should be height. And this should be width. Okay, good. I'm glad that this wasn't a square, because that would have thrown me for the real input. Okay, so let's see. $31. Perfect. Okay, that's exactly what we're looking for. So let's get rid of all these print lens. So I guess the answer really is to just continue. Just keep looking, because we hit a dead end, I guess. So bacon. Run. All right, so that should still be 31. And now let's change the test input to be the real input. So input 202212.text. There we go. And the answer is a panic on line 76. It couldn't find a shortest path to the end. Oh my God. Oh, right. That was a change I made before. 468. And it was the wrong change to make, and I left it like a big dummy. And that's the right answer. Okay, thank goodness. That was a struggle. Epic Blog, you had asked me earlier if I was struggling over things. Well, we found it. This is saying something interesting here. We don't need to do a map on that. Right, we can just do copied. And I knew that too. I knew that. I just, in the heat of the struggle. Okay, and that doesn't change the output there. So 468 for 497. So it takes almost 1 millisecond per step. All right, git status. Git add source. Git commit -m 2022 day 12 part 1. That took a long time. That was, I think that's been the longest. Got through Monk says, now we're talking. Well done. And Big Large cheers. Yay. Thank you. Thank you. I'm here all week. Actually, the rest of the month. Okay. So the next thing we need to do is part 2. As you walk up the hill, you suspect that the elves will want to turn this into a hiking trail. The beginning isn't very scenic, though. Perhaps you can find a better starting point. To maximize exercise while hiking, the trail should start as low as possible, elevation A. The goal is still the square marked E. However, the trail should still be direct, taking the fewest steps to reach its goal. So you need to find the shortest path from any square at elevation A to the square marked E. Oh. I'm going to brute force it. There's probably a smart way to do it, but I'm going to do the dumb way. So 2212. What I'm going to do is I'm going to pull all this code out. I'm going to refactor it into a separate function. And then I'm going to loop over it with different starting point each time. Because right now the way we start is here, self-start. This is the only reference to self-start, I believe, in this function. Oh, I lied. Okay, these are the only 2 places where we reference self-start in this function. So let's refactor this whole thing out and just pass that in, right? So pull this all down, and we can just have it return shortest, right? So find shortest. We'll give it a self, and we'll give it a starting point. Which is just going to be let's do a reference to a usize, and then just return a usize as the distance, which is going to be this line here, right there, except I won't put it in the create output. And there's probably some other things I'm going to need to move around, but let's find out. So I should be able to say here, self find shortest from self start, and see if that's still 468. I don't know how I deleted that U there. And it doesn't like this. Expected something. Oh, I have to asterisk it. Okay. And it's still 468. We're not using start point. Thank you, Rust. That would have been a bad bug to have to track down. Come on. Rust again saves the day. Oh, expected tuple. Can I get away with this without having to worry about borrowing and mutating? Okay, good. 468. Okay. So now, how do we want to do this? We can loop over the grid and find all of the row calls, and then just loop over that and find the min on the shortest. That's going to take a little while. How many A's are there? Let start points is equal to self grid enumerate. No, iter enumerate. That'll give me the rows. And for each one of those, I'm going to map row point. Oh, I forgot the dot. Still doesn't like those. Why? Line. And then I want to say line dot iter enumerate, and that'll give us the call and a character. We can filter. Oh, I know why, because I didn't do this, right? Yeah, that's a usize, and that's a vec of u8s. And now this is the column, and this is the because I have two dots. Yep. Okay, that's the usize and u8. So we're going to filter any ch that's equal to an a. Filter that and then map it. Can I do this? Call ch. How do I do this? Row call. Can I reference that row that's up there in the map? Wow. And then collect. I have no idea if this is going to work. We can't compare that to that, so I have to double start, or I can put a... Okay, so why can't I do this? Help wrapping inner types in a tuple. I did. I wrapped it right here in a tuple. That's a usize. Oh, okay. So we're mapping this here, and then so this needs to be. Oh, I don't know a good way to do this. All right, maybe the simpler approach is to just use a pair of for loops for row line in self grid iter. Enumerate for call ch in self grid row iter enumerate. And then we can just say let mut start points equal to vec new. If comma if ch is equal to a. This is all I was trying to do with this explosion here. Start points dot push row call. And I'm just going to print out the number of starting points we have. There should be a way to do this with iters and maps and everything like that. Oh yeah, I can use line. Why don't I use line since we have it? So there's 1850 A's in the thing if I did that correctly. And now we just want to find the min. So this is going to be find shortest. So we're going to say start points dot iter dot map point self find shortest point min on ramp. And that might take forever to run. Or it could just panic. That might be another solution. Oh. What if there is no path? What if we found an A that doesn't have... I'm not on the test input anymore. Let me switch over to the test input so that we can determine whether or not... because there could be an A that doesn't have an out. This one says 29, so that works. 29. Okay, so the logic is correct. We just have to deal with the case where we don't have a shortest path because a starting point is stuck, right? You can't get from where you're trying to go from. So we can change this to an option and then filter out right? We're going to have to change part A, or part 1 rather, to assume that we have an answer. And then just change this to a filter map, right? Expected usize found usize. Copied. Why? Oh, because of this thing. I can... This is saying I can do this in order to extract it out. Okay. It's still 3129. That's the good news. Let's try it with a real input now. (2022) 12. Let's see if it panics. It is taking a very, very long time, isn't it? Okay. You know what I'm going to do? Just because. Cargo run. I'm just going to see if this speeds it up at all. I'm imagining that most of the CPUs being used for checking bounds. No, we still check bounds with release builds. There must be some other things. Oh, see, that was a lot faster. It was just about 3.3 seconds. Let me try running it here and see how long it takes. But we have the answer. 459. Ta-da! That's the right answer. Oh my goodness. That was a bit of a struggle, but we got there. It took less than an hour, so not too bad. Let's see what we look like here. Did I crack? Oh, I did. I finally cracked 20K. Yay. So I guess this was a harder problem for people, or maybe Monday is not a... But you can see for me, I did start late. But you can see I normally finish, although this was my previous longest one. So, yeah. A little bit longer. Okay, so it took almost 36 seconds to solve in debug mode. So it's 10 times as slow. This is obviously not the most efficient way to do this, right? Just search everyone. There's got to be a better way, as they say in the movies.